Hello everybody! Today I will show you a little application that I wrote which simulates the motion of planets. I have a bunch of planets here in this little scene. So this is supposed to be the Sun. Right here, that's Mercury. This is meant to be the Venus. We have Earth here, we have Mars, and we have Jupiter. Saturn ought to be somewhere. This little red arrow up here shows me where to look for it, for the currently selected planet, which it tells me about right here. So that's Saturn, and there is Uranus, Neptune is there, and Pluto somewhere in the far distance. Let's go back to the Sun. Just for reference, there are static stars which won't move at all, and they don't have to do anything with the real constellations of stars. They're just randomly placed. Okay, so I can now start this little simulation, which means it actually goes through some numeric processes to figure out where the planet should go based on the interactions, on the gravitational interactions of those planets. So I can blend in and blend out those traces, but let's leave them out for now. It's going to make things a little easier to see in just a minute. That's not why I wrote this simulation, especially since there are programs which could do exactly this for you. What this is supposed to demonstrate is the so-called apparent retrograde motion. So what is this? In order to show this, I need to look from one planet to another. So I can now say let's look from the Sun in the direction of the white arrow right towards Jupiter, which is right here. Actually, what's seen from the perspective of the Sun is shown in this little frame down here, which I can enlarge a little. So now we can see a little arrows symbol here, which indicates the direction of its movement. Since I messed up signs, this is apparently pointing in the wrong direction right now. I need to fix this in a minute. Anyway, it shows the absolute value, so the speed of this planet down here, and since I only messed up the sign, that actually matches what's outputted, so that's the speed of the planet. And as we can see, as seen from the Sun, there's close to no alternation in the speed of Jupiter. So we don't see any so-called apparent retrograde motion. Let's look at this from the perspective of a different planet, say from Earth. So I'll jump towards Earth. Well, no, I jump back to looking at Jupiter, and now I jump to Earth. Venus, Earth. So now what we can see down here is the Jupiter as it can be seen from Earth, and that's actually true if you stare up into the night sky, and you do that every single day of a full year, you will actually see this. But obviously I can speed things up a little here, so if I increase the speed, we can easily see that Jupiter starts to move in one direction very quickly, then stops again, moves in the opposite direction again, going back and forth. So that's apparent retrograde motion, and that's why I wrote this little application to demonstrate that effect. Thank you.